So hello and welcome everybody, and first of all I wish happy Diwali to all of you. And today is a day for laws of motion. Since this is a quick revision video, if you have already completed laws of motion and after that you have to revise this chapter laws of motion, so mainly it is of class 11th or for JEE mains and NEET, and this is a quick revision video, but it can be in 2 or 3 parts. So today is the part number 1 for laws of motion. First of all, we'll be discussing some very basic things in laws of motion such as forces, then equilibrium and the Newton's 3 laws of motion. So those kinds of first of all basic things we'll be discussing in today's lecture. After that, in part 2nd and maybe part 3rd, we will be studying more and more things, and later we'll try to solve the JEE and NEET problems over the Newton's laws of motion. So here first of all, since the topic name is laws of motion, first, since so many days we were discussing over kinematics. Kinematics is the study of motion without studying the causes of motion. Okay, only we study about the terms in motion such as acceleration, velocity, displacement, distance, speed, those kinds of terms. In those kinds of terms we can study in kinematics. But dynamics means the study of causes of motion such as force. Okay, dynamics, just like in dynamics we can study about the laws of motion, because laws of motion describe about the cause of motion, because since we know cause of motion, what actually is, that is force, and laws of motion mainly deals with the force, such as first law of motion also deals with force, second also, and third also. So this is mainly a part of dynamics. So first of all, since we will be starting from very basic thing, and that is force in this chapter. Okay, so first of all we'll be starting from force, and everybody know that force is a push or pull that can change a state of motion, rest or direction, shape or size of any object. But these are very basic things. Since now we are studying this chapter for JEE, so mainly here what we can study, first of all about the 4 fundamental forces of nature. So there are mainly 4 fundamental forces of nature. They are natural forces, they are not any kind of external forces, and those 4 forces are, first of all, let me write here, gravitational force. Okay, first among them is gravitational force, and just after gravitational force we can call the next force as weak force, and after weak force, EM force. To EM force in full form you can call as electromagnetic force, and after EM force we discuss about strong force. Okay, those are called the 4 fundamental forces of nature. So mainly if we talk in strength about the strongest force among 4 fundamental forces of nature, so there's no force that can stand in front of the strong force in the matter of strength. It is the strongest force, since by its name we can get a strong force, so it is actually the strongest force. After that, the strongest is electromagnetic force, then is weak force, and finally is gravitational force. So from this 2 conclusion we can get, actually in the matter of strength, okay, in the terms of strength I have written in order, in ascending order from weakest to strongest. Since by this we can get that strong force is the strongest force among all the 4 fundamental forces of nature, but gravitational force is the weakest force among the all 4 fundamental forces of nature. But how strong and up to what range can they be applied? So if we want, we can compare all the other 3 forces with the gravitational force. So let me write in short form G, W, EM and S. Okay, if I try to compare their strength with the gravitational force, so gravitational force is just 1 times stronger than itself, just 1 times, because gravitational force, just like how we say that the object is in rest or motion, in kinematics we deal with such problems, we need a frame of reference. From the frame of reference we see here, actually if we connect this to that, so mainly gravitational forces are frame of reference, because we are just trying to compare the 3 forces with the gravitational force. Okay, Later, weak force. Let me tell you a very important point, that weak force is just 10 raised to the power 25 times stronger than the gravitational force. And electromagnetic force is 10 raised to the power 36 times stronger than the gravitational force. If we talk about strength, while our strong force, that is the last force among all the 4 fundamental forces of nature, and the strongest one, that is 10 raised to the power 38 times stronger than the gravitational force. So here, which last 3 forces we have compared them with the gravitational force. Okay, so this is the matter of strength. This we are mainly discussing about strength of the forces. Okay, means actually how powerful the forces are. But if we talk about range, so first and third, okay, G and electromagnetic, okay, those forces are called the long range forces. They are known as of long range forces. Okay, G and EM means gravitational force and electromagnetic force, while second and last means weak force and strong force. They are known as short ranged forces. Okay, because they are just of very short range. Just like, let me tell you, just like gravitational force, we have gravitational force also acts between earth and moon. It also acts between earth and sun. Since we know sun is very far from us in space, very far, but still gravitational force of the sun acts over the earth. So from this one very nice and interesting conclusion we can get, that gravitational force is just a long ranged forces, and like this is electromagnetic force, because it is also a kind of, it is also just like it can be very similar to gravitational force. Just like if I write gravitational force as F, then F is equals to what? G m1 m2 by r square, where r is the separation between the particles. So of course gravitational force depends over the separation, but as much this separation goes, but even then gravitational force will get less and less. But finally this is that gravitational force magnitude doesn't become 0. But if such a thing happens, that the separation between them is just like infinity, so in that case maybe it happens that the gravitational force magnitude becomes 0. But up to this time we haven't come to the such kind of separation in which the magnitude of gravitational force is 0. So that's why gravitational force and electromagnetic force are called the long range forces. But this W and S, all the weak and strong forces, are known as short range forces, because they act over only the nuclear distances, means the distance up to 10 raised to the power minus 10 meters. If the distance is bigger than this, so they can't act. Then the magnitude of weak force and our strong force, their magnitude will directly shrink to 0. So finally we can say that if we have just like our R, imagine that the separation between two particles is R. If R is less than 10 raised to the power minus 10 meters, then we can call that the weak force and strong force can act between them. But while if R means the separation between two particles is greater than 10 raised to the power minus 10 meters, then strong force and weak force can never act. So this is a very fundamental and very really nice and interesting rule which we should surely remember. Just like example if we have to take, so we can take of 10 raised to the power minus 15 meters. Since 10 raised to the power minus 15 meter is just lesser than 10 raised to the power minus 10 meters, it means that weak force and strong force can act here, and weak force and strong force can together be called the nuclear forces. Okay, they are part of nuclear forces because they also act inside nucleus, and they can also act over the nuclear distances. So this is about the fundamental forces of nature. And now since we have already studied about the 4 fundamental forces of nature, now we'll move to the external type of forces and try to deal with them. So first of all, let me rub the board. Okay, so since we have already studied about the 4 fundamental forces of nature, now imagine such a case. That's really very interesting case. Okay, so imagine we have any kind of block that is kept over the surface. Later what happens that I apply from here any force, any external force, and imagine I am present and I am an external agent and I apply any external force F over the block. So later what will happen? Of course, imagine this is the x-axis and this is the y-axis. Later I am making the angle theta. I am applying the force F by making the angle theta with the horizontal x-axis. Then what will happen? This component at the x-axis, x component of this force will be what? It will be F cos theta. We can tell y component of this force will be F sin theta. We can tell. Now here it is really very interesting and very important point to remember that F cos theta is here referred as the tangential force. Okay, if I write here F cos theta, okay, means so F cos theta I can refer as tangential force or tangential F. Just like F I am representing generally by force. So this is our tangential force. Tangential force means just like we can define that if we apply any force over any kind of particle, then what happens? Acceleration is produced to the particle, and so after acceleration is produced there is some change in velocity. So tangential force actually mainly F cos theta means the x component of that kind of force which is applied by making angle theta with the horizontal x-axis. Mainly this F cos theta changes the magnitude of velocity. So it is directly linked with the change of velocity. Okay, change of mainly our mode of velocity vector means mode of vector v. Because if we have tangential force, imagine here the particle is moving in this direction with constant velocity. Later I have to make it faster. I have to make it reach anywhere, but it is going with constant velocity and very slow. Later I by any external agent, if I am an external agent and I apply force by making the angle theta with the horizontal x-axis to move it faster, so which magnitude of change of velocity of the block will be? That will be caused using my F cos theta or my tangential force. But if I have to change the direction of velocity, then what will I do? So here which F sin theta is present. Okay, F sin theta. So F sin theta, okay, this mainly changes the direction of velocity. Suppose that velocity vector I have in this form, ai cap plus bj cap. So it is directly linked with the ai cap plus bj cap. It directly changes the ai cap plus bj cap. It changes the unit vectors. Means we can call that if I have any kind of normal force, this is referred as normal force. If you want, you can also write here normal force or normal F. Just like this we call as the tangential force, but F sin theta we refer it as normal force. Means since we know normal force acts perpendicularly, we can call. So here it directly is linked with ai cap plus bj cap if this shows the direction of velocity. So totally, since we know a and b are constants, but mainly it deals with the I cap and j cap because it has to change the direction of velocity. It wants, since F cos theta directly changes the magnitude of velocity and F sin theta mainly changes the direction of velocity. If any particle is moving like this and if I have to change the direction of velocity of the particle to this direction, so what I will have to do? I will have to mainly apply F sin theta or a normal force so that the direction of velocity of the particle will change. So this is also referred as the normal forces. You may have also read it. So this is about tangential force and normal force. This is. But here after force, if we have already dealt with force, so we can also deal with acceleration, because since we know, let me write here first of all. Okay, so acceleration means what? Acceleration, if I write as vector A, then vector A I can write as d vector v by dt, means the differentiation of vector v with respect to t. And since vector v if is a function of time t, okay, if vector v is a function of time t, so we can differentiate it and whatever is coming, that is acceleration. Means already in kinematics we deal with acceleration, means the rate of change of velocity. And else to this I write acceleration as vector f by m. Why do I write such? Because we write as vector f is equals to m times vector a. That's why this is known as the second law of motion already, since Newton's second law of motion predicts this rule. So if according to this we are going, so a vector a is equals to vector f by m. So here dv by dt is also equals to f by m. This also I can write. But there is very important and interesting point about acceleration in this chapter. Since already we have studied acceleration in kinematics, but in this also we have to study to introduce to us some new kinds of terms. If we take the same kind of diagram, or if we take the same situation, then of course first of all the particle was moving with constant velocity. Suppose v in this direction. Okay, we have already supposed v. Okay, since it was changing, this tangential f was changing the mode of vector v, while this was changing the direction of vector v. So if v is in this direction, so of course when force vector f we are applying in this direction, so there will be caused some acceleration, because when net force is not zero, then the net acceleration is also not zero. Here net force is not zero, then the net acceleration of the block will also not be zero. So according to this, if we are going, so acceleration is not zero, so there will be some acceleration. And that kind of acceleration, let me tell you that first of all when vector f we are applying, so it first of all, do you know what it does? It produces an acceleration, and then acceleration changes the velocity. Because since up to now we were studying that the whenever force is applied, so velocity changes. Okay, of course we are studying this, but actually directly not. Force indirectly changes the velocity. Directly, if there is no acceleration produced in the metal, so there will be no change of velocity. Force work is only to produce an acceleration, and the acceleration, since it is itself rate of change of velocity, so acceleration is the cause of change of velocity. So actually the cause of acceleration is force, while the cause of velocity is acceleration. So this is the term. First of all, force causes acceleration, and acceleration causes the change in velocity. Then of course if the acceleration causes the change in velocity, so acceleration should be also grouped into two categories, tangential and normal. Okay, so acceleration also we can group into two categories. First we can write AT as tangential acceleration. Okay, this is the tangential acceleration. Of course by name we can study tangential acceleration means the kind of acceleration which helps any particle to change the magnitude of its velocity, means it directly is linked with the mode of vector v, just same like that. And later what happens, later comes the normal acceleration, means an means normal acceleration. Okay, and it is directly linked with what? Again the direction of vector v, means it changes the direction of vector v, or the direction of the velocity of particle. Again in this case the tangential was changing the mode of vector v, and this normal was changing the direction. And in this case also same thing happens, only what it does, this first of all tangential f first of all produces tangential a, and tangential a later produces a change in the mode of or modulus of vector v, or a change in the magnitude of vector v. And same thing happens with normal force, normal acceleration, and the change in the direction of vector v, or the change in direction of our vector velocity. Since velocity is already a vector quantity, then this is known as the tangential acceleration and normal acceleration. But if we want a total acceleration, just like Newton's second law, already since if you have studied your books NCERT, H.C. Verma, D.C. Pandey, S.L. Arora, any kind of book, in that of course it is mentioned that the acceleration, net acceleration is net force divided by mass over mass of the system. If there is an acceleration of the system, okay, then mass of the system. Then here in this case what we can see, that this is which kind of acceleration, tangential or normal. So let me tell you, it is neither of those, because this acceleration generally we write as net acceleration. So what is net acceleration? Actually it is also referred as total acceleration. But how to just like how we can find out total acceleration if tangential acceleration and normal acceleration is given? So we can do it. There's a relation between total and tangential and normal. That relation is A total is equals to the root of at square plus an square. This is a very important relation, that at is equals to root of at square plus an square, means the total acceleration of the particle is equals to the square root of at square, means tangential acceleration squared of the particle plus normal acceleration squared of the particle. So if we are doing this, means here we are getting the total acceleration of the particle, and according to this we can write that this is equals to what? F by m. Vector F by m. Of course we are getting this, of course, but if you want, just like tangential acceleration, if we want its formula also we can write. Since we know that net acceleration already I have written here F by m, so if I want, so I can write that at means tangential acceleration as F cos theta divided by mass, because since we know tangential acceleration means just tangential force. In tangential acceleration we include the tangential force, and tangential force means just F cos theta. So here at the place of only F will include F cos theta by m. And if we want the normal acceleration, so normal acceleration we just write as F sin theta by m, because normal acceleration is produced due to the normal force, that means F sin theta. So F sin theta divided by m. So those are also two very important formulas. So if we want to just derive that acceleration, just like since we know that acceleration, net acceleration is net force. If we want net force, we can do divided by mass. If we want to derive, so we can also using this those three identities we can derive. So only what we'll be doing, that we can also verify it, just like root of at square plus an square. When we'll do, means the root of F cos theta by m whole square plus F sin theta by m whole square. So what we'll be getting? Of course F net by m. So we can also derive this identity using those three formulas. So if we want to, so we can also do it. So this is about acceleration. Now only what we'll be going to do, we'll be going to study about the static equilibrium. So first of all, let me rub the board. Okay, now here we can see, now we'll be dealing with the static equilibrium. Okay, so since equilibrium already you may have studied, equilibrium means that the sigma fx is 0, then sigma fy is 0, and then sigma tau is also 0 about any axis, it is also 0. So here what we can see, that the x component of all the forces is 0, the y component, sum of y component, actually here is sum, or net we can call, net y component of all forces is also 0, and net torque about any kind of axis is 0, then the forces are said to be in equilibrium. But what is meaning of a static equilibrium? Since equilibrium you may have read in your textbooks, but static equilibrium, what is meaning of that? So here we can see that if sigma fx and sigma fy is 0, then of course we can, through this we can get a very nice conclusion that sigma ax is 0 and sigma ay is also 0, because when net force is 0, then the net acceleration also becomes 0 according to the Newton's laws of motion. So if this is 0, then this results to very important conclusion that the velocity vector v is either 0 or it is vector v is equals to any constant. Because when there is no acceleration produced in any block, suppose any block we have, later what happens, there is no acceleration, it moves with any velocity. Okay, so here suppose any block of any mass m we have, particularly suppose that mass of this block is m, later it is moving with constant velocity here v, imagine constant. Okay, so suppose that this kind of particle is moving with constant velocity. So later what will happen? Suppose here v equals to constant. So if it is moving with constant velocity, means the rate of change of velocity itself will be 0, means the rate of change of velocity will be also 0, or acceleration of the particle will be 0. Acceleration becomes 0. Now if we have such a case, suppose again the same particle I am putting here, same mass of mass m, and suppose that this time its vector v is equals to 0. Then what is the acceleration? Then again acceleration is again 0. So from here we get two conclusions, that whenever the velocity is constant means the acceleration is 0, and whenever the velocity is 0 then the acceleration is 0. Same thing is present here, only by an example I have defined it. So here I can define this easily. In both cases acceleration is 0. So from here a very nice conclusion we can take, that whenever, suppose that this is for constant velocity means the particle is moving, just like when we took example of constant velocity, then the particle was in motion, but we need such a kind of equilibrium in which the particle is at rest. Static equilibrium means, first of all, sigma fx is 0, sigma fy is 0, later sigma ax is 0 and sigma ay is also 0, but velocity is not constant. Velocity is only, vector v is only 0. Such a kind of equilibrium means we can call that the net force and net acceleration is 0 and the velocity of the particle is also 0. So we can take an example, just like is in such a case, what is the net force acting over the block? Here I can write that sigma fx is 0, sigma fy is also 0. That's why velocity is 0. So if such a conclusion we have, so either velocity can be constant, or because acceleration is 0 then velocity can be constant or 0. But this one case, not this one case is not possible, but this one case which we had, this is known as the static equilibrium. So we can call that the particle was under static equilibrium. That's why sigma fx was also 0, sigma fy was also 0 and sigma ax was also 0 while sigma ay was also 0. That's why the velocity or the vector v of the particle was also 0. Means such a case in which those the following particle is just like considering the following those kinds of rules, then that kind of equilibrium will be called the static equilibrium. So this is my today's topic, mainly based over the laws of motion, and in its part second we'll deal with more kinds of concepts in laws of motion, because there are many still more concepts such as friction and many those kinds of concepts. So this was my today's topic, and thank you to you all.